Hello students, today we are going to learn about circumcircle of a triangle. To know circumcircle of a triangle, we have to draw the center of that circle first of all, we have to find out the way to get there, and then we learn about how to draw that circle and its various kind of properties. Let's move on. This is the triangle we are talking about, and these are three vertices. First of all, we have to draw the perpendicular bisect of three sides. Now, we start with BC. Say this is the perpendicular bisect of BC. Suppose this point is D. Now, BD equal to DC. Why? Because D is the midpoint of B and C. Now, again, if we do the same thing with the AC, and let's not forget, this is the 90-degree angle. If we do the same thing with AC, we will get this line, which is making 90 degree over here, and say this is the point E, where E is the midpoint of AC. That means this part is equal to that part. AE equal to AC. Okay. Now you can see these two bisects meet at a particular point. Let's say that point is A's. Now you can ask me that why I didn't draw the perpendicular bisect of AP. This is pointless, because if we draw that line, it will obviously go through that point A's. Okay? If you feel any doubt, you can draw on your own to check whether I'm correct or not. Ace is equidistant from B, C and A. Now we have to understand how it is happening. How we make that point is equidistant from every 3 points. Now, for that reason, we have to look at another aspect. Say this is BC, and we have to take the perpendicular bisect of that line. So we have drawn this. Now, this point is D, as we have shown here. So, D obviously is the midpoint of BC, means D is equidistant from B and C. So my question is, if only that point has the property to be the equidistant from B and C? No. All along the line, if we get any point, numerous points are there, each and every point is equidistant from B and C. This is the property of perpendicular bisect. Say this is the point S. This point S is here. So obviously, according to that logic, SB equal to SC. So we can write SB equal to SC. Okay? So the same thing, if we apply here, that S is on the line of perpendicular bisect, which is of AC. Now S is actually equidistant from A and C. We can write SC equal to SA, which is making sense. Means S is actually equidistant from A, B and C. So if we get the compass and put here and take the distance SB or SA or AC and make a round, it will obviously touch A, B and C. This is actually circumcircle of this triangle. So we have known now the technique of drawing the circumcircle. Similarly, the circumcircle has a center. That is called circumcentre. This is the circumcentre, and if we draw that circle, that is circumcircle. So we have learned to draw the circumcircle of any triangle. Now we have to discuss about the various properties of it. We have to know various aspects of this circumcircle. For a case, we have taken the right angle triangle, where this is the 90 degree. Obviously, this is the hypotenuse. Height, base and hypotenuse. You know how to draw the right angle triangle, right? Now, if we take the circumcircle of that right angle triangle, you may ask me, oh, what is the special about it? Actually, this hypotenuse is becoming diameter of that circle. Diameter means this is the diameter, and obviously the center would be the midpoint of the diameter. That means the hypotenuse. Okay, so now if we take the names A, B and C of the right angle triangle and take the name of that midpoint D, and if we connect DB, where this circle is the circumcircle of this triangle, we can write DA equal to DC equal to DB. This is a special property of the right angle triangle which is having circumcircle, where hypotenuse is becoming its diameter and its midpoint is becoming the center, means circumcenter. Okay, so now move on to the another aspect of circumcircle. You can see we have drawn three triangles, and the first triangle is acute angle triangle. So what's special about this acute angle triangle? If we draw the circumcircle of it, circumcenter will be inside the triangle. This is the right angle triangle, case number 2. If we draw the circumcircle of this triangle, the center would be on the side of this triangle. Now, this is obtuse angle triangle. If we draw the circumcircle, the circumcenter will be outside the triangle. This is the special case of three kinds of triangles. Please note it down. Let's move on to another topic. This is a special case of a circumcircle of a triangle. Now, if we take the circumcenter ACE and join BACE and SC, we are getting it as central angle. BCR is holding the central angle S and the angle at the circumference A. These two angles have some relationship in between. What is that? Actually, this angle is half of that angle. Example, like if this angle is 80 degrees, obviously it will be 40 degrees. Why? Because it is the half of that central angle. Condition that the two angles should be holded by the same arc. Now to the another property of the circumcircle. Say this is the circumcenter again, ABC is the triangle again. Now let's connect A, B and C with S. Since S is the center, so SB is the radius of that circle, SC is the radius of that circle, and SA also a radius. So this SB equal to SC and obviously equal to SA because these are all radii. If we look at this triangle, the name of the triangle is SBC. This triangle. This is isosceles triangle. So what kind of property isosceles triangle has? Actually, isosceles triangle has two equal sides and obviously two angles are equal. Means these two sides are equal, so opposite angles are also equal. The angle opposite to this SB is this angle. Let's take it as X, and similarly this will be X because these two angles are same. The same property we can put here for this triangle. We take this angle as Y, again this angle as Y. Again, for the same property, this triangle has also this angle as Z. Similarly, this angle as Z. Look at the triangle of ABC. It has three angles which are X plus Y plus X plus Z plus Y plus Z equal to 180 degree obviously because a triangle has 180 degree in total angle. Now the equation has everything double. 2x, 2y, 2z, which is 2x plus 2y plus 2z. I have taken 2 as common. We can know. Taking 2 to the other side, we are getting x plus y plus z equal to 180 divided by 2, which is equal to 90. This is the special equation formed by the circumcircle property. I hope you enjoyed the properties of circumcircle. Okay, good night. Take care.